G'day, Year Nines. Let's have a look at the answer to some of these questions. The first question is around index laws. So the first question asks: 7 multiplied by 7 multiplied by 7 by 7. 7 multiplied together 4 times. Does it equal 7 to the fourth? True or false? The answer is true, because if we look at this, the base is 7. Okay, because we've multiplied. The thing we multiplied together is 7, and we've done it 4 times. So it is definitely 7 to the 4. Hopefully my drawing will pick up as this goes on. Let's have a look at the next one. 5 times 5 times 5, a bunch of times together. Well, we can see from this, the base is going to be 5. And if we count the times together, 1, 2, 3, 4, 5, 6, 7, it's going to be 5 raised to the power of 7. Next one. This time we're using letters rather than numbers, but the base is going to be a, and we've got a raised to the power of 3. It's multiplied together 3 times. Next one's a little bit trickier. We can see we've got 3 different bases in here, all multiplied together. Some level of A, some level of C, and some of B. So let's just work this out. We've got 1, 2, 3, 4. 4 lots of A, so it's A to the 4, 2 lots of C, A to the 2, and 4 lots of B. So we can simplify it using index rules saying A raised to the power of 4, C raised to the power of 2, and B raised to the power of 4. So let's go to scroll down a little bit further as we keep going through these. Next one, we have a slightly different rule. We've got 2 things multiplied together, C3 times C3. We can actually rewrite this. So I might just do it really quickly, even though I know it's going to be great with a pen. C cubed is C times C times C, and C cubed again is going to be C times C times C. So we can see that's going to equal C raised to the power of 6. There is a rule we've got, remember here too, that C to the 3, when we do it from the start, C to the 3 plus C to the 3 equals C to the 3 plus 3, and we get to the same rule at C to the 6. So we can remember by the rule, or we can just work it out that way. Next one's a little bit different, right? So C to the 3 cubed. So that's C times C times C 3 times. C times C times 3, and then we do that 3 times. So we can probably see that we're going to get C to the 9. The rule here is it's going to be C to the 3 times 3, which is C to the 9. If you want to go right back to first principles, why is it like that? Well, C to the 3 is going to be C times C times 3. C, when you multiply it together 3 times, you're going to get C times C times C, times C times C times C, times C times C times C. Next one's a little bit different because it's got a 3 in front of the x. So we've got to cube both the 3 and the x cubed. Let's remember our rule. X cubed to the 3, we're comfortable that's going to be x to the 9. We looked at why that was in the last problem. And 3 cubed is going to be 27. So it's going to be 27x to the 9. I'm sorry that the numbers aren't great there. Next one, we're back to a similar rule. It looks a little trickier because we've got a, just going to move it down a touch, because we've got a negative in there. But we're still going to do exactly the same. We're still going to do exactly the same thing. Let's make it blue for a little while. We're going to add them together. X to the 4 times x to the minus 2 is going to be x to the 4 minus 2, which is going to be x squared. If we want to think about it from first principles, x to the negative 2 is really just divided by x squared. It's x4 divided by x squared. The next one's a rule, a really important rule. Anything raised to the power of 0 just equals 1. You can Google it and look it up. You get reasonably long explanations, but it's best just to remember the rule. T raised to the 0 just equals 1. Now the next one, I might try and set this one out according to first principles so we can have a little look at it, right? So there's a little bit of writing too. We got 6, we got 6 to the 7. So 6 times 6 times 6 times 6 times 6 times 6 times 6. 6 to the 7 divided by 6 to the 3. 6 times 6 times 6. Okay, now we can see that we can do some cancelling of these. This will cancel out here, this will cancel here, this will cancel here. So we're left with 6 to the 1, 2, 3, 4. 6 to the 4. Okay. Now that's what I expected, because 6 to the 3 down the bottom, that's also the same as saying 6 to the 7 times 6 to the 6. Whoops. 6 to the 7 times 6 to the minus 3, which would equal 6 to the 4. So we've got two different ways of doing that. We can write it out and work it out. But just remember that rule. If it's down on the bottom, it's negative. Negative 3. So 6 to the negative 3. 6 to the 7 times 6 to the negative 3 equals 6 to the 4. We're just about through our index rules. Right, so now we can start to multiply some numbers out a little bit further. Okay, so here we've got 5x cubed times 3x squared. So we can start by saying, well, 5 times 3 we know is going to equal 15. So that's going to be the first part of it. Then we look at our x's. X squared multiplied by x to the 3. Remember our rule. In this case, we add them together. It's going to be 15x to the 3 plus 2, which is 15x to the 5. So that's going to be our answer there. Next one's the same, just looks a bit more complex to make it harder. So let's multiply the numbers together. 4 times 11 is 44. And then we've got x cubed times x to the 4. So that's going to be x to the 4 plus 3, x to the 7. And then y's, we've got y squared, y to the 2 plus y to the 3. 2 plus 3 is 5. So we've got y to the 5. So that's what we have to do when we see those numbers here. Next one is a little bit trickier because we've got brackets and we're raising everything to the power, plus we've got the 3 outside. So let's do the brackets first. Let's leave the 3 here. Let's change our numbers so we're clear what we're doing. Let's leave our 3 here. And let's think about what we've got here. The first thing we can do is raise 3 to the power of 4. So that's going to be 3 raised to the 4 times. Now, d to the 3 raised to the 4. Remember our rule, we got brackets, we multiply here. So we can have d to the 3 times 4, which is 12, and b to the 2 times 4, which is 8. So now we can just multiply this through. 3 times 3 to the 4. We've got 1 more times 3 to the 4 multiplied by 3, so that's going to be 3 to the 5th. D to the 12, B to the 8th. The next one we've got, we might just have to give ourselves a little bit more room here, is a little bit of a dividing one. Okay, so you're going to have to simplify this out. So let's think about the things we can simplify first. 40 divided by 10. So the two numbers, 40 divided by 10, that's going to give us 4. P to the 4 divided by P to the 2. So that's the same as P to the 4, which I'll just do over the side, is P to the 4, 1, 2, 3, 4. Divided by p to the 2. So we can either remember and cancel 2 of them out, and that leaves us with p squared, or we can remember our rule, p to the 4 multiplied by p to the minus 2. If it's in the bottom, it's a minus 2. It's going to leave us with p to the 2. And q to the 6 divided by q is going to leave us with q to the 5. So that's going to be our answer there. Very much the same thing we've got here. very much the same thing we've got here. So that's going to equal 4 divided by 2 is going to equal 2. A cubed divided by a squared, so that's at the top. We're going to have a times a times a divided by a. So 2 of the a's are going to cancel out. We're going to be left with 2a and b to the 5. So it's b times b times b times b times b divided by b to the 3, b times b times b. So they're going to cancel out as well, and we're going to be left with b squared at the top. I might just do this a little bit of a longer way so we can see exactly what's happening. If we can just expand it this way. 4 is the same as 2 times 2, and then we've got a cubed. So that's a times a times a, and then we've got b to the 5. b times b times b times b times, oh, that's all gone horribly wrong. So if we remember that we've got 5 b's up there, and then down the bottom what we've got, is a 2, 2 a's, and 3 b's. So let's get to work and cancel some of these out. We get rid of one of each of these 2's. We get rid of 2 a's, and we get rid of 3 b's. The b we can't. Oh dear, it's gone wrong again. The first one will be the b we can't see. And then the next 2 should be that one and that one, and we're left with b squared. So when we've cancelled everything out with 2a b times b, which is b squared.